So this is a Linux task manager that I created for my Advanced Operating System Principles and Design class. So to start the application, the first thing you do is go to the correct directory and then run the command sudo python3 gui.py. Once you run the command, you can go to any browser and go to this address. This will open up the task manager. Since it's built using web technology, it's responsive. But for now, let's compare some of the values that are shown in my task manager versus the system task manager. So the Linux system comes with a task manager called System Monitor. And as you can see, the values in the task manager for Linux and my task manager are pretty close. There are some variations because of the interval in which the values are collected, but in the system monitor, they show the CPU utilization per second, whereas in mine, you can control the time interval in which the values change. And also you can see the user mode and sys mode per CPU, unlike in the system monitor. And also we have the graphs similar to the system monitor. We also have the number of interrupts per second, and the context switches per second. The next thing we have is the memory and disk statistics. So in the memory statistics, we have 27% utilization, similar to what's shown on System Monitor, and even the megabytes, the number of megabytes translate to the number of gigabytes correctly. As for disk, we have SDA and SDB. These are the two disks that I have. I do have a USB plugged in right here, SDC, and when I unplug it, it automatically detects that and removes it from the values. So next up, let's look at the processes. So in the processes tab, we have all the processes that are currently running on the system shown. So if you compare that to top, it should be similar to top. We have the name of the process, we have the process ID, we have the user, we have an extra inode number if there's any open files related to that process. It shows the inode number for that file. We also have the user time, sys time, CPU utilization, virtual memory utilization, and physical memory utilization. See, this virtual memory utilization maps to this values right here, and this physical memory utilization maps to this %mem value right here. As you can see, all the values are pretty much identical, maybe off by a couple of percentages. We also have the user time and sys time here, unlike in the top command. So an extra feature in my application is the end task button, which can kill certain tasks that are running. But before we show that, let me show you the Python 3. So this is my application, the current utilization for my application. It's around 10% all the time during my testing. So we can also search for top. Top is, so if we sort top by name, so if you click on the end task button, it will kill the top command. So next, let's look at the network utilization and the TCP UDP connections. So as you can see, we have a TCP tab with non-established connections and 5 established TCP connections showing. So I'm gonna start a new tab, and then let's go to YouTube, and then try running a video and then see if the number of connections go up. Oh, also we have this network tab, which shows you the utilization of the network. Let's click on one of these videos, and as you can see, the receiving and average utilization goes up. We also have the TCP tab, which the number of connections have also gone up from, I believe it was 6 before, now it's 10. So there's that, and then we have the UDP connections also. So we can also see the TCP connections using SSH. So here we can see that a new SSH connection has started. Last but not least, we have the keylogger section of the Linux Task Manager. For this, I created a LKM, a loadable kernel module, which can log the keys pressed on the device. So I'm running this on a virtual machine because this is an experimental thing. It's not really something you would use in real life. So the idea is that once you turn the keylogger on, it will create a new file called keylogger under the proc directory. And using this command, we can see the status of that file. So currently it's not created, but once I turn on the keylogger, it will automatically create the file in the correct directory. And if I type something and press enter, it will show up on the GUI on the front end with the date and time of when it was typed. Shift key also works, and delete key also works. So another thing that works is the caps lock. And then we also have the number keys with the shift. And then also implemented Control A or Alt A or any of the keys pretty much. And then we also have Tab and Escape also working. So that's about it for the keylogger. We can turn it off and see that the file gets deleted.